गुड मॉर्निंग फ्रेंड्स, मीट नॉलेज हब में आपका वेलकम है। और इस सीरीज़ में हम स्टार्ट करेंगे सेमीकंडक्टर इलेक्ट्रॉनिक्स का पार्ट है। 12th में इम्पॉर्टेंट होता है, 12th के लास्ट बुक में होता है, लास्ट चैप्टर्स में। और उसके बाद बीएससी, एमएससी एंड स्पेशली बीटेक का ये टॉपिक रहता है। तो फ्रेंड्स, इस सीरीज़ में एक्चुअली आपसे फ्रेंड्स में से कुछ लोगों ने बोला था कि इसकी जो है रिवीजन सीरीज़ हमें दी जाए। तो ये लेक्चर पूरा रिवीजन सीरीज़ के लिए है। इसको मतलब जिन्होंने इस टॉपिक को ऑलरेडी नहीं पढ़ा हुआ है तो वो भी सुन लें, क्योंकि ये एक्चुअली स्टार्टिंग से और बेसिक है इस टॉपिक का, तो ये आपको हेल्प करेगा। Now friends, let's start this topic with atomic structure. The size of atom is so small that it is virtually impossible to see it even with the most powerful microscope. So a guess is made regarding the possible structure of atom which should satisfy the properties that studied experimentally. And various scientists have given different theories regarding the structure of atom, and the study of Bohr atomic model is adequate. Now we will discuss more Bohr atomic model. According to Bohr, the electron can revolve around the nucleus only in certain permitted orbits. Orbits of certain radii are allowed. And the electrons in each permitted orbit have a certain fixed amount of energy. So now we will discuss about that levels of energy and then energy bands. We know that each orbit has fixed amount of energy associated with it, and the larger the orbit, the greater is its energy. It becomes clear that outer orbit electrons possesses more energy than the inner orbit electrons. And the given figure is known as energy level diagram. The first orbit represents the first energy level, the second orbit indicates the second energy level, and so on. Now, energy bands. Okay. In case of a single isolated atom, the electron in any orbit possesses definite energy. However, an atom in a solid is greatly influenced by the closely packed neighboring atoms. The result is that electron in any orbit of such an atom can have a range of energies rather than a single energy. This is known as energy band. Let's discuss important energy bands in solids. As discussed before, individual energy levels of an isolated atoms are converted into corresponding bands when the atom is in a solid. There are a number of energy bands in solids, and the following are the particular importance. First is valence band and second is conductance band. Now we will discuss first type of band, valence band. Okay, the range of energies possessed by valence electron is known as valence band. Electrons in the outermost orbit of an atom are known as valence electron, and valence band has the electrons of highest energy. This band may be completely or partially filled. For instance, in case of inert gases, the valence band is full, whereas for other materials, it is only partially filled. The partially filled band can accommodate more electrons. Next is conduction band. In certain material, the valence electrons are loosely attached to the nucleus. Even at ordinary temperatures, some of the valence electrons may get detached to become free electrons. In fact, it is these free electrons which are responsible for the conduction of current in a conductor. For this reason, they are called conduction electrons. The range of energies possessed by a conduction band electron is known as conduction band. All insulators have empty conduction band, and it is partially filled for conductors. Discuss forbidden energy gap. The separation between conduction band and valence band on the energy level diagram is known as forbidden energy gap. The width of the forbidden energy gap is a measure of the bondage of valence electron to the atom. The greater the energy gap, more tightly the valence electrons are bound to the nucleus. No electrons of a solid can stay in a forbidden gap, as there is no allowed energy state in this region. And the difference in the behavior of solids as regard their electrical conductivity can be, we can say, beautifully explained in terms of energy bands. So we will discuss classification of solids based on energy bands. Three types of solids are there according to this classification. First is insulator, second is conductor, and third is semiconductor. So let's discuss insulator. Insulators are those substances which do not allow the passage of electric current through them. In terms of energy band, the valence band is full while the conduction band is empty. Further, the energy band gap between valence and conduction band is very large. mostly approx to 15 electron volt as shown in figure. Therefore a very high electric field is required to push the valence band electron to the conduction band. So and also this information is important for us. An insulator has negative temperature coefficient of resistance. This conductors are those substances which easily allow the passage of electric current through them. It is because there are a large number of free electrons available in a conductor. In terms of energy band, the valence and conduction band overlap each other as shown in figure. Due to this overlapping, a slight potential difference across a conductor causes the free electron to constitute electric current. Now the third type is semiconductor. Semiconductors are those substances whose electrical conductivity lies in between conductors and insulators. In terms of energy band, the valence band is almost filled and conduction band is almost empty. Further, the energy gap between valence and conduction band is very small as shown in figure. Therefore, comparatively smaller electric field is required to push the electron from valence band to the conduction band. So at low temperature, the valence band is completely full and the conduction band is completely empty. Therefore, a semiconductor virtually behaves as an insulator at low temperature, and however, even at room temperature, some electrons cross over to the conduction band, imparting little conductivity to the semiconductor. As the temperature is increased, more valence electrons cross over to the conduction band and the conductivity increases. This shows that electrical conductivity of a semiconductor increases with the rise in temperature. Therefore, a semiconductor has negative temperature coefficient of resistance. Let's discuss the main topic of this lecture, semiconductor, with its definition. The resistivity of these materials lies in between conductors and insulator. For example, germanium, silicon, selenium, these are some examples of semiconductors. Now let's discuss properties of semiconductors. The resistivity of a semiconductor is less than an insulator but more than a conductor. This is first property. Second is semiconductors have negative temperature coefficient of resistance. And third is when a suitable metallic impurity is added to semiconductor, its current conducting property changes appreciably. Next is bonds in semiconductors. In semiconductors, bonds are formed by sharing of valence electrons. Such bonds are called covalent bonds. In the formation of a covalent bond, each atom contributes equal number of valence electrons, and the contributed electrons are shared by the atom engaged in the formation of the bond. Hence, each valence electron of an atom forms direct bond with the valence electron of an adjacent atom. For this reason, valence electrons in a semiconductor are not free. And also, all semiconductors have crystalline structure. This is commonly used semiconductors. The two most frequently used material are germanium and silicon. It is because the energy required to break their covalent bonds is very small, being about 0.7 electron volt for germanium and about 1.1 electron for silicon. Let's discuss about germanium and silicon. Germanium was discovered in earth metals in 1886. Germanium has become the model substance among the semiconductors. The main reason being that it can be purified relatively well and crystallized easily. Generally, recovered germanium is in the form of germanium O2 powder, which is then reduced to pure germanium. And next is silicon. Silicon is an element in most of the common rocks. Sand is silicon dioxide, and silicon compound are chemically reduced to silicon, which is 100% pure of use as a semiconductor. Now the question is, why germanium has become the model substance among the semiconductors? Then answer is because germanium has very small energy required to break their covalent bond, and it can be purified relatively well and crystallized easily. And the next is energy band description of semiconductors. A semiconductor is a substance which has almost filled valence band and nearly empty conduction band, with a very small energy gap, nearly approx to 1 electron volt, separating the two. It may be seen that forbidden energy gap is very small, so even at room temperature the number of free electrons available is very small. Therefore, at room temperature, a piece of germanium or silicon is neither a good conductor nor an insulator. Now next is effect of temperature on semiconductors. We can define it in two parts, at absolute zero and above absolute zero. Now first is at absolute zero. At absolute zero temperature, all the electrons are tightly held by the semiconductor atoms. The inner orbit electron are bound, whereas the valence electron are engaged in covalent bonding, so there are no free electrons. In terms of energy band description, the valence band is filled and there is a large energy gap between valence band and conduction band. Therefore, no valence electron can reach the conduction band to become free electron. It is due to the non-availability of free electrons that the semiconductor behaves as an insulator. And then above absolute zero, when the temperature is raised, some of the covalent bonds in the semiconductor break due to the thermal energy supplied. The result is that a few free electrons exist in the semiconductor. These free electrons can constitute a tiny electric current if potential difference is applied across the semiconductor crystal. This shows that the resistance of a semiconductor decreases with the rise in temperature. As the temperature is raised, some of the valence electrons acquire sufficient energy to enter into conduction band and thus become free electrons under the influence of electric field. These free electrons will constitute electric current. It may be noted that each time a valence electron enters into the conduction band, a hole is created in the valence band. These holes also contribute to the current. Okay, now let's discuss hole current or hole. When a covalent bond is broken due to thermal energy, the removal of one electron leaves a vacancy, therefore a missing electron in the covalent bond. This missing electron or that vacancy is called a hole, which acts as a positive charge. For one electron set pair, one hole is created, therefore thermal energy creates hole electron pair. ओके तो नाउ टाइम हो गया कंप्लीट और बाकी का जो पार्ट है वो हम नेक्स्ट लेक्चर में कवर करेंगे. ओके